Before proceed to the valedictory function, Dr. Lijo Paul, the coordinator of the FTP, this is the current FTP, he will be briefing on the research activities going on at SJCET. Dr. I would like to introduce Dr. Lijo Paul before you. Dr. Lijo Paul currently is the Dean PG of SJCET. He completed his MTech from NIT Surat and completed his PhD from IIT Madras in the year 2015 on manufacturing engineering. He has over more than 20 international and national level journal papers into his credit. With this short introduction, I would like to welcome Dr. Lijo Paul to this session on the research activities going on at SJCET.
Thank you, Pradeep, for your nice introduction. So before we go up with this FDP, so what we thought is we'll just tell you some preliminary works that we have started in our institute. So actually, there in the initial time when we planned, we have a session on the research in detail of SJCET, but later we got the scientists from ISRO, so we have rescheduled the program in that way. So I will be telling you in another 10 minutes, like some of the 2-3 works we already finished with respect to the 3D printing levels. And currently also many more works we are planning to in the beginning stages are there. So we'll be just introducing you how the works are going on. So most of these works are taken care by the here by the graduates and postgraduate students as well as the research scholars. Especially Mr. Pradeep, who introduced me, is a research scholar here. So he's also working in the area of 3D printing itself. So during the slides, you will be getting a glimpse on some of the various some of the domains we started. So we are also planning to go ahead as the funds are coming up for the programs. Okay. So coming to the research works that is going on at SJCET, St. Joseph College of Engineering Technology. So this is one of the work that is currently almost in the complete stage by Ms. Anjali Vinod. She's a graduate here. She has made investigation on the 3D printing cardiovascular graphs. So what we tried to make is she tried to study especially the aorta, that is a part of the blood vessel. So she tried to model it. Then she went through some of the softwares that we already went, like IDMA case and all. She tried to slice it, and she able to produce the products both with the SLA machines as well as with the FDM machines. So it was a comparison and stress analysis. So due to the pandemic situation, it was not in the full scene, but whatever the best way she could do, she has able to do. So we'll be just having a glimpse. So it was actually, we tried to generate the CAD model from the CT scan model she obtained from the hospitals. And she tried to manufacture the cell vessels without scuffers, which is, and she tried to make a material that is especially PLA, which is shown biocompatible. And this is a product she has made initial drawings from the, this is a aorta, she want to make it. And this shows the part of the hearts where the vessel is coming, and she taken out a single with the actual dimensions, whatever is inside. So with this initial drawings, she sliced it and she tried to produce STL file, as you can see in the screen, an STL file of a dimension similar to that of this. Then we tried to make this in the, first we tried with FDM process, a few step post modeling. And then we found it is the finish and all, it is not that much good, because the surface finish we found it is very low. Then we went to the SLA machines where we used the PLA resin in that one also to make the product. So you can see a glimpse of the drawings she made for the dimensions and all for this work. And later we went to the production of this. So this is actually the printed part with the SLA, the FDM machine. So it's a PLA is used as a filament here. And this is printed with one of our partner in Bangalore. We, because of Corona situation, we are not able to do the exact work in our labs. So we have a partnership with the institute in Bangalore. So we asked them to give all the dimensions and all. So they were able to give us the according to our dimensions. They given the FTM as well as they have given the SLA. So this is the SLA products, and we have received the products, and we have found the surface finish and all. One is almost like glassy finish if you're taking SLA products, and because it is a resin is used in that, and very better finish we are able to attain in that. And in that they have given it is UV rays, because we have not seen that machine. It is in Bangalore. They have given the products only. So whatever they have informed, we are able to get the products and we compared it, and that was a initial level project work she is able to do in this area. Another work what we tried is actually club foot treatment, especially trying to make a fabrication of a belt, especially the children's which are born with some feet defects in the feet. I think the first session Mamilla, Dr. Mamilla sir has touched on the topics, like how they are using the various biomedical products to make that. So here also we this is only the preliminary stage. We made the product with the basic designs you can see here. So this is a normal foot and this is a club foot, some defects here. So we want to give a support to the back part of this. So we designed that part and we tried to produce that in the FDM process itself. You can see the product we tried to make. So there are some clamps and clips are there, that is not 3D printed, but the all the assembled supports, what are the supports mechanism you are seeing here, that is actually using the 3D printing machine. That is also we approach the Fab Lab in Trivandrum, and there we are able to according to our design. This is done by one of our MTech graduate, and in our advanced manufacturing. So they are able to produce this according to our design. They are able to give the products to us. So you can see the basic product that is we made with the 3D printing. So this is the part where you are keeping the feet with a small shoes, and the small two belts are there to support. So currently, what people are working is actually with the plaster of Paris. The what used to do in the medical side is we have to make a plaster of Paris to the foot of the children, and you have to keep it for some period of time. And after some 3 to 6 months, you have to check it again. You have to put another new plaster of Paris, and it is will be a bit heavy weight. And for the children's within 2 years of age are suffering with this, and they have a lot of problems while using that. So this is a this types of products like it has a mechanisms to adjust, like a ratchet and pole mechanisms are provided to adjust the feet size, and as the feet comes erected, we can adjust the uh, this dimensions properly, so that it will be a great support to the children's without any coating, plaster of Paris coating we can avoid to some extent using this. So that was a one work. And this is actually another work, scoliosis. As you know, there is a problem with your backbone. So some problem with the backbone, we call it just some bending or small bending. So usually we have to give the belt, people has to put around their stomach, and to give support to their backbone. So usually that will not be biocompatible materials, and the dimensions of that one will not be uh, according to the requirement of the patient. So here we used a material called TPU. So that is a biocompatible material, and we made a design and we made the products. Right now I don't have the actual picture of this. Anyway, we have just like a belt with a clipping, so you can just put it around your wrist, and it will be you can change the as it comes erect. You can adjust the your this belt around your wrist, so that it will be very comfortable, and the material is lightweight as well as it is very compatible, biocompatible materials. So that was these are the different views of the belt the students are able to produce with the 3D printing, and is also basically an FDM product only. And this is the first work we started with this. This is a 3D printer filament, actually from the waste plastics. And this one we got a small funding from our KTU under SJCET student project. So 50,000 we got some funding. And with this, what we try to make is especially the plastic bottles. So you see around any places, it will be thrown into the street all around. So it is actually a environment problem where you are getting this plastics throwing around your area. So what we try to make is you such plastics we try to collect it, and we try to use a extruder, and we try to made it into fuse to form a filament. So that is actually you can see the some of the glimpse, especially these types of bottles, which we will be throwing out to the surroundings. It's a HDP quality plastics we used. So we collected one type, especially the this which are used in the bathrooms and all, cleaning bathrooms and all. Such one we collected, we shredded, and we made a shredder. We made it the shredding part we done outside, but the this one that is extruded part we made here in the campus itself. It is in our lab. So this shredded material we fed into this extruder, and there is a heating coil we kept inside, through which we are heating to a lower than the melting point, but above the plastic, near to the plastic deformation stage. We made it, and that was made into a filament like this. So the plastic which is shredded and fed into it, and we made a filament like this. And this filament we made it extended to make it straight rod, and we used this is a basic 3D printer we purchased in our lab using the KTU fund, CERT funding we received. And in this printer we are able to make some small products. It's a BTech level project, starting project we done. And this machine, basic machine, this is costing around 25,000 only, and this is in our lab, and we are doing some basic operations using this 3D printers. And this is extruder, it is made as a part of that project work, which used to put the shredded plastics to get fused to make a filament. And this is actually an environment friendly project where we are converting the waste plastic into a 3D printing filament to some extent. So we can see some of the glimpse of the various stages by which you're taking it out, and how these are various parts of the extruder machines students are able to make. And this is the printer we purchased, in the sense we assembled it, various parts we purchased and we try to assemble it. And this is a basic printer, as I told you, M8, and nozzle diameter 0.4 mm. And these are some of the spec which is used in the material. So PLA and ABS, we use PLA material in this. Right now we are doing the basic BTech as well as basic MTech projects in this machine with the PLA filaments to see how it will come out. And these are the filaments, and these are some of the basic products like sheets, some shapes they are able to produce as a part of the preliminary works. And this is a current we one of, as I told you, Mr. Pradeep, who is doing the PhD works. He got a CERT funding, and under that is we are in the move to purchase a SLA machine, basic SLA machine. And we already kept the orders, and we're waiting for this machine to come to start the SLA works, that is the 3D printing with SLA machine. So these are some of the specifications of the machine we are in the mode of purchasing, especially the build size with 14.5 to 18 this bed size we are using. And we are trying to make a biocompatible products as a part of his research areas. So this is an overall glimpse of the various works which is currently going on, and we are in the we are trying to go for more funding, so that as the funding we are receiving, we'll be trying to put more effort in these areas. So we are going to start the validatory function. So as a part of this FDP, it was the last 3 days. We were going through various domains from the IITs and INTs, ISRO, as well as various biomedical areas we have touched. And we hope the participants have received a good data and good information about all the sessions that went on. And now I request a few participants to give some feedback. You can unmute and you can tell how you felt about this, and you can tell some suggestions which you feel, which maybe we will be trying to impart next time when we are organizing another FTP. So I request the participants to tell a feedback on the FTP.
Hello, good evening. Am I audible? Lijo sir?
Yes.
Good evening, one and all. Myself is Sebin Paul, working as assistant professor in mechanical engineering department at Vishwari College of Engineering and Technology. So first of all, I would like to thank the Department of Mechanical Engineering and all the coordinators of SJCET for conducting the FDP on 3D printing and additive manufacturing. So FTP was well organized and it was executed in a systematic way. As we all know, the first day we got an idea about what are the basics of this additive manufacturing. So we all know about subtractive manufacturing, material removal process, but additive manufacturing is a new development. So it is we all know got an idea about the additive manufacturing. What is additive manufacturing and what are the different additive manufacturing techniques and what are the research opportunities. So first section was dealing with the basic concept. Coming to the second day, I think that was the one of the best things or one of the highlighted things of this FDP. We got an idea about what are different softwares used for this 3D printing of purposes like Cuba, Idea, Maker. So those softwares, they have introduced those softwares. Then also we have got a hands-on experience. Even though there was limitations of this online FDP, yet it was a very useful section. We could understand what are different operations, how that can be performed. So that was one of the highlight of this FTP, I think. Then coming to today's section, again, it was mainly based on the applications of this 3D printing techniques, where we can use this 3D printing technology and what are the applications. So those things we got an idea about from this today's sections. Also, finally, Lijo Paul also explained about what are the research things and what are the works going on at SJCET Palai. So all these things were executed in a well planned way, and there was continuation from the beginning itself. Each sections was very much well organized. So I think it was very useful for me because I am planning to do some research work. Currently, I am MTech. So for me, I think I can get some idea from these things, and I can work on that with the help of various source persons. So overall, it was a very useful FDP. So I again thank all the coordinators, especially Lijo Paul sir, Pradeep sir, and all the coordinators, and also the Department of Mechanical Engineering for conducting such a useful FDP. So with these words, I conclude.
Thank you.
Thank you all.
Thank you.
So any other feedbacks or suggestions from the participants? Yes, sir.
All such, I am Chandrasekhar Nair, formerly with Vikram Sarabhai Space Center, retired in 2010, so around 11 years back. Even though this 3D printing system have been in force in Western countries, even in ISRO it was not there at that time, when till I was working. But I was exposed to this area when I started taking class for S1, S2 students of the KTU. And I'm very grateful for this program because now I have got a better exposure on this. I can use that information to new students. At the same time, I feel suggestion-wise, my suggestion is we can include some quality control aspects and reliability level aspects in the such new manufacturing techniques.
Sure.
How we ensure those things. Of course, our ISRO person, when our I think his name is Alex.
Yes.
Mr. Alex has presented certain areas, but in all other areas, if we are able to include this quality assurance aspects also, it would be always better, because then only the seriousness of the this technology, everything will come. Because when our in 8-9 sessions, each one was great presentations, because it opened our eyes to the technologies, the materials, processings, then post-processing, importance of post-processing activities. All those things have come up through all these 9 sessions. It was great, really great. Thank you for the organizing the whole thing. I had come to your college earlier, maybe
Yes, sir.
during that fuel cell FDP,
Yes,
right?
sir.
And I was really fascinated with the facilities in your college.
Thank you.
Thank you very much.
Thank you very much. Thank you.
Okay, myself, Jason George, National Professor in Mechanical Engineering at Presided College, Mala. So, first of all, I'm inviting Pradeep sir for sharing some experience.
Thank you, Jiffin. In fact, we have come to the end of our 3-day FTP on additive manufacturing and 3D printing, which is actually sponsored by KTU, Kerala Technology University. Hope you have benefited out of the program, the FTP, which actually includes 9 technical sessions originally, of which 2 sessions are dedicated to have hands-on experience, especially on 3D printing softwares like Cura and Idea Maker. I would like to thank the resource persons, various resource persons, and the participants to turn out and make the sessions interactive in between. In fact, looking forward to meet you again for a different or similar area in the near future. Thanks once again. Jai Hind.
Thank you, Pradeep sir, for the wonderful words from your side. Then I'm inviting our HOD, Dr. Binoy sir, for sharing the experience.
Good evening, everyone. We had wonderful sessions in this FTP program, like additive manufacturing techniques for product development, then hardware and software for 3D printing technology, metal 3D printing, then application of 3D printing technology in aerospace and biomedical area. Hope those sessions of this FDP enrich your knowledge. Let me come to my duty. First of all, I thank our principal, Dr. J. David, whose valuable guidance and encouragement made this FDP a successful one. My sincere gratitude to our management for the support and encouragement. My heartfelt thanks to Dr. Lijo Paul and Mr. Pradeep P V for the wonderful coordination of this successful FTP program. Next, I would like to thank all the resource persons who involved in this FTP for their informative speech. Last but not the least, I thank all the faculty members from various institutions who are participated in the FTP. Thank you.
Thank you, Dinesh sir, for the wonderful words. Then I'm inviting Dr. Lijo Paul sir for the to share some experience about that.
Yeah. Once again, I thank all the participants, and we are coming to the last part of this FTP. And last 3 days, we were going through the various sessions, especially with the talks with the IITs, NITs, ISRO, and the scientists from various fields. And we are very happy to see the participants who are present throughout all the 3 days for the programs, not only from Kerala, but also across the nation. People are there, especially the MTech students, PhD scholars, also all the faculties in various institutes have taken up initiative to come for this program. And we are very much happy to see that we are able to complete all the sessions in the given stipulated time in a best manner as possible. And we are very much sure that most of the sessions were very informative, and it has given the glimpse of what is the process is all about, 3D printing is all about, and also it has given us a better idea on the applications, especially how this process is used in the biomedical industries, also especially in space applications. Especially we have seen today's session metal 3D printing, which is a emerging area, and also we have seen the bio ink and biomedical devices, which are also a emerging area in this 3D printing. And I'm sure especially the faculties who are pursuing their PhD works as well as research scholars and MTech students who are attended this program got a good benefit on their research side. Like there is a lot of scope, a lot of space, a lot of areas to cover, and the future is 3D printing, especially in the manufacturing side. And I hope most of you will be able to attain your goals, especially in the this 3D printing, the various research papers we expect to come up from your side as a result of this program. And we are also trying to go ahead with the research works in the 3D printing, because it is a lot of industries are in this field, a lot of institutes are in these fields, and it is very easy to since we already have the contacts with these people, professors and scientists, we can use these contacts to keep in touch with them, and you can send mails to them, and we will be sharing their mail IDs, and they will be giving the phone numbers once you contact them. We cannot give the phone numbers directly to you because it is a personal thing, so we'll be sharing with you the emails. So those who are interested, you try to contact these experts through emails, and try to keep in touch, and try to visit their institutes, and try to get your products, maybe 3D printing done in this institute, so that it will be a great support. And before saying the last words about this FTP, you have seen the people came from IITs, NITs, ISRO for this, and all these people, how they came to this FTPs through the, I have attended last year a lot of adult FTPs, especially in the 3D printing and all, and we have got a lot of emails and a lot of contacts. So through the contacts only we are able to get these people for these programs. I don't have any personal contacts with any of these people who presented to you during this session. So what I'm telling you as a faculties, it is up to you. You can make these relations to build up, and you can ask them to come to your institutes for this online or offline FTPs, and that way we can develop a culture, so that it will be benefiting not only to the faculties but to the society also. If you have a good Sundays in the institutes, maybe in the Kerala, if you take our K2 institutes, maybe very few institutes will be having the 3D printing facilities. So so we have to make a tie-up, and we have to make a contact, so that we can visit these institutes wherever the facilities are available, and our students, especially the BTech, MTech, as well as the PhD scholars who are working with you, should work on those sides and try to make that contacts and see that a good results will come out at the end. That is the aim of this FTP as a whole. And I hope we are able to reach our aim to enlighten you throughout these 3-day sessions. And once again, we thank you, and we are coming to the ending of this session. So thank you very much.